Hello, so today I'm going to be talking to you about speed, velocity, and acceleration, and basically some key differences. What are they? How do we use them in physics to define motion? All sorts of that stuff. So first I want to talk about speed. So speed. So this is the simplest of the three, but you could probably know this one right off the bat. It tells us how fast something is moving, right? So sorry about that. And the formula for that is speed is equal to distance over time. So, for example, if a car travels, let's say 100 kilometers in 2 hours, so its speed, if we want to calculate speed, we know speed is equal to distance divided by time. Time. What we would do is we would input what we have. So, question says if a car travels 100 kilometers in 2 hours, what is its speed? Well, we have the distance, which is 100 kilometers, and we have the time it took to travel that distance, which is 2 hours. So we just input 100 kilometers and 2 hours, giving us 50 kilometers per hour. So that's how you find the speed of things. And speed is a scalar quantity. And what that means is basically it only has magnitude. Yeah, speed has magnitude only. There's no direction associated with it. That's velocity, and I'll get into that. But that's what scalar means. There's no direction, only magnitude or size. Like if I say if a runner is moving at 8 meters per second. That's a speed because it tells you how fast I'm telling you how fast the runner is moving, but I'm not telling you which way. So that's speed. That's the simplest. Let me get into velocity now. So velocity, so what is it? Well, I would say velocity is closely related to speed. Okay, that's kind of a weird but it just includes one extra piece of information that makes it different. So basically, velocity is the rate of change in displacement. And if you don't know what displacement is, I'll get to that in a second. Rate of change, sorry for the bad handwriting, of displacement. So just to put that in simpler term, so sorry, in simple terms, velocity is speed but with direction, which is exactly what I was saying earlier. Because speed doesn't give you direction, it just gives you how fast it's moving with direction. So let me elaborate on that. But first, let me give you the formula. So the formula for velocity is displacement, and I'll get to what displacement is in a second if you don't know what it is. It's represented by this symbol, delta D, with an arrow above, and time, usually represented with delta T. And the key word here is displacement. So instead of with speed it was distance over time. In this case, it's displacement. So as we know, distance is the total path traveled. Right? But displacement is the straight line change. Actually, let me write that down real quick. Straight line change in position, and it has direction, unlike distance. That's another thing. Distance is scalar, so it doesn't give you a direction, but displacement is vector. It's a vector quantity because it has direction and it has magnitude. So let me give you an example on that for just for the people who aren't familiar. So let's use this color, I guess. So example, let's say you walk 10 meters east. Let me just draw this real quick. So that's east and west, 10 meters east, and then 10 meters west. So your distance traveled would then be 20 meters, right? Because that's the total path traveled. You walked 10 meters and you walked another 10 meters. There's no direction for distance. But your displacement would actually be 0 meters because you started here. Let's say you start there, then you walk 10 meters. Let's just say that's 10 meters. 10 meters east, and then you walk 10 meters west. So, did your net position really change at all? Not really. You went back to the same place you started. So, that's the difference between distance and displacement. Displacement talks about your position, but distance is just talking about the total path traveled. And this is why direction matters because let me so velocity must include direction. Such as 15 meters per second north or 30 kilometers per hour east, or actually even negative 5 meters per second. We can say like east, because negative in this case usually indicates the opposite direction. This would actually be 5 meters west. But because yeah, because velocity has both magnitude and direction. By the way, magnitude isn't just another word for size. That's why velocity is a vector quantity. So I think that's enough about velocity. I'm gonna go talk about acceleration. Alright, so let's talk about acceleration, which is usually sometimes misunderstood. So most people think acceleration only means speeding up, right? Like you're accelerating in a car, you're speeding up. Yeah, that's kind of, let me just rewrite that actually. So someone's like, oh, I'm accelerating in a car, I'm speeding up. That's acceleration. That's only like half of the definition. So this is wrong. That's incomplete. So this is the kind of definition, or yeah, kind of definition. So acceleration, we can say that it's the rate of change of velocity. And I just explained to you what velocity was. It's right. It's like speed, but with direction. So here's the formula. Formula for acceleration. It's acceleration is velocity over time. So what you can notice about all three of these, they all have time. They're all dividing something by time. Because yeah, so let me just write this a different color. So because velocity has direction, acceleration happens when you sorry, can you stop saying when you speed up, you slow down, or even if you change direction. So yeah, like someone said, a car speeding up, that's acceleration. A car braking can also be acceleration, but negative, negative acceleration. And a car turning a corner at constant speed, that's also acceleration. Even if your speed stays the same, changing direction means your velocity changes, so that's why you're accelerating. This is also why objects that are moving in circles are always accelerating. Also, planets orbiting the sun are accelerating. A car on a curve, that's acceleration. So these are all examples of acceleration. Another notable thing, acceleration is also a vector quantity because it has, of course, magnitude and direction. Obviously, because it has velocity included in it, right? So now, so just to wrap this up, let's compare all three of these now. So speed, we know it's scalar. Formula is distance over time. No direction. And we know it's, I forgot to mention this, but speed is always going to be positive. Because even if you like slow down all the way to zero, it's just going to be 0 meters per second. It's never going to be negative. And velocity, we know that it's vector because it has magnitude. Okay, it's vector. Formula is displacement, which is represented by that symbol over time. And it has direction. And it can actually be positive, negative. Okay, wait, let me just do this then. Or it can be positive, negative, or even just zero. This one can only be zero. And acceleration, we know that it is a vector quantity. It's change in velocity divided by time. So the formula is velocity over time. And it occurs when speed or direction changes. And that's a summary of how speed, velocity, and acceleration are all different. So that's the video. I hope you enjoyed watching. Please like and subscribe. If you watched to the end of this video, I really appreciate that. Thank you for watching. Please like the video. God, that's kind of a bad thumbs. I'm not gonna. Okay, so like the video, subscribe. If you would like more videos based on physics, maths, or chemistry, you can comment what kind of topics you would like to see. But that's all for now. So see you.